Hello, everyone. Thanks for being here. My name is Stephane Cordova. I'm the CEO of Intento Design, and I'm going to introduce you to our solution to speed up your analog design flow with our product called IDXplore. So first, let's start by a quick introduction about the company. So we have been founded in 2015 from Sorbonne University in Paris. Our R&D is located in France. We are both in Paris and Grenoble area in France. So we have 15 employees and quickly growing. And our technology is patented worldwide for all the product that we are having at Intento. So what we do at Intento is developing software for analog designer. So we have today two main products. One is IDXplore. That's the one I'm going to introduce to you today. And the second product is IDSubstrate, which is a sign-off tool to prevent latch up and other substrate effects. So we will have, I'm sure we'll have other opportunity to speak about this very interesting tools. So now let's focus to IDXplore and let me give you some inputs about analog design. So as you know, the world is analog, and the analog circuits are everywhere and are in charge of many different functions in systems. So of course, power and battery management, communications, audio, sensors. So, and I'm sure that I'm forgetting a lot of other use. So the analog devices are quite crucial in application today. And the specificity of analog design is they are technology dependent. So they need to be redesigned every time you want to design it to move it to a certain process or foundry. And the other thing that it's important, unlike the digital design, analog design flow is still quite manual, with a drastic impact to time to market and cost. So clearly, we need to innovate in this field, and we need to bring new EDA tools because we have very big challenge in front of us. And I think the first challenge for me is analog designer are becoming rare. The hiring of analog designer for our customer is tough, and the learning curve to reach a certain level of know-how is getting long. So, and in the meantime, the demand for analog is booming due to the fact that you have new application driving this market. So, of course, electric vehicle is one obvious market driving analog business. And you have also the modern digital SoC integrating more and more analog blocks. You have transceiver, ADC lag, PLL, interface. So the demand clearly on analog is booming. And what is also specific to analog, it's the challenge to get an optimum design is very costly because you need time to do the analog design. You need engineers and you need hardware resources. So the cost of analog is not low cost, it's really high cost. And as the semiconductor industry always expand, always increase fabs, the capacity, and also the range of silicon technology, they always invent new technology. It adds a big pressure on analog designer because they have to make sure their IP has to work with all the process which are available, or at least all the process that their customer asks to support. So I'm referring, for example, for an analog IP supplier, they have to make sure that their IPs works in any process used by their customer. And of course, we can't afford to have multiple spin of your design. So you have to make sure that your design is good the first time, and you cannot not capable to do multiple trial for your design. So as I just mentioned, analog design flow is still quite manual. So here, as you can see in the screen, so one of the key steps of the analog design flow is the DC bias and transistor sizing, and these key steps is still manual, and you still have a lot of time consumed by this step, with an important impact on the overall project execution. So this is the reason why we have developed IDXplore at Intento Design. We wanted to develop a tool to assist the analog designer for him to focus on important architectural innovation, while the tools, IDXplore, handle what is repetitive and laborious in the design. And IDXplore starts from the designer recommendation and propose a large choice of valid configuration. And I will, of course, show you it in the next slides. And IDXplore is fast and easy to design and migrate across any technology and any foundries. And again, I'm going to go in more detail in the coming slide. So here is how become the design flow when we integrate IDXplore. So as you can see, we are not changing the flow. We are just adding our tools into an existing flow without changing the flow itself. We're just adding these tools, replacing a manual task, and bringing much more value and much more speed up on the flow, because we bring automation in the flow, helping the designer to go quickly with this task of transistor sizing. So IDXplore is based on cognitive technology with the purpose to accelerate the design of analog IC. And our technology, in fact, quickly transform the designer inputs into a formal graph inspired by the designer knowledge. And after, IDXplore generates a graph that will explore the design electrical performances with the same way the designer will explore the design. So the exploration is very fast and generate a lot of valid solution for the designer to select the most optimized solution for his design. So of course, always the final decision will be made by the designer. So our tools is here just to assist the designer and give him the opportunity to go faster in the flow. So as you have seen, IDXplore is integrating in the design flow, and here you can see what are the inputs of the tools and what are the outputs of the tools, what is generated by IDXplore at the end. So we start, of course, from the schematics, from the data, technology data, and from the test benches. And IDXplore is in charge to generate design solutions, give multiple ways to analyze those solutions. So you will see graphical ways are available. And of course, at the end, we will generate a size schematics, back-ended schematics that can be used to continue the flow, going to the layout or other flow. So here is an example of a screenshot of the design exploration. The interest of IDXplore is its capability to perform very quickly many different design configurations. So here, number one, you can see that the IDXplore has generated 12 valid configurations. And you can see on the block 2, these are all the details of a certain configuration with the parameters, the performance, the size of the transistor, all the data which are generated by the tools, by IDXplore, are available for the designer to check the result. And then we have also added a graphical view of analyzing the parameters. And this is what you can see on the block 3. Here, it's more graphical way to see where are the different parameters and how they are centered into the specification, for example. This is another screen which is used to go a bit deeper in the analysis. So here you can do the analysis parameter by parameters. So you can observe the behavior. So you select one solution which has been generated by IDXplore. And then you can decide to observe, analyze specific parameters which are key for your design. And you can use this graphical way to observe these parameters. Now you have better understanding what IDXplore can bring to the designer. So let me share with you some use cases with customer example. And we start by an example where the customer has been able to reduce and optimize his design thanks to IDXplore. So in this case, we had 10 regulators in 40 nanometers with an initial target to complete the design in 3 months, reduce the die area by 20%, and increase performance of key parameters. So what we do, we work with our customer using IDXplore, and we have been able to achieve the work in less than 4 weeks. We've been able also to reduce the die area by 50%. And in the same time, we've been able to improve performance of key parameters. So at the end, we exceeded the targets, both in execution time and in performance, because the designer had the choice among different solutions and was able to select the one respecting all the targets, but in this case, even going further and achieving better die area reduction and better performance. Another example is to use IDXplore for design migration. So there are many use cases for design migration, the need of design migration. The first is manufacturing transfer. For example, you want dual sourcing or you want to increase your production capacity. So you have an existing design in internal fab and you want to externalize with your foundry partners. Then the other is, for example, a good example for IP provider. And you want to migrate a design to a more advanced node, usually for cost reduction purpose or just for fulfilling customer requests because the customer asks to get to receive an IP from a very advanced node. So of course, as an IP provider, you need to design this IP to this new node. And as I explained at the beginning, as we are changing the process, we need to redesign the IP. So here with our tools, we propose very fast and easy way to migrate because we can reuse what was done on the initial design. So let me share a concrete example that we had with a customer. It is a LDO IP initially designed with a TSMC 55 process. And the target was to migrate this IP to Global Foundry 22 nanometer process. So here you have the initial specification. Here you have the specification of the design TSMC 55. And here you can see the result of a Global Foundry 22 nanometer design that has been migrated by IDXplore. So it's very interesting to show that in terms of performance, we've been able to achieve much better performance in some cases for some key parameters. Of course, getting the die reduction thanks to the node, the change of the node. But going to another node being able to design very quickly, to migrate very quickly this design, and still being able to improve the performance was a very good achievement for the customer. And of course, and this is the main interest of IDXplore for migration. It is its capability to save the design time, because we reuse constraint from the initial design. So we are not starting from scratch. We are reusing constraint from the initial design. And in this particular use case, the tools has been able to generate 36 valid configuration over 62 exploration. IDX just take about 5 minutes in the simple 4-core computer. So as you can see, it's very fast and don't need a huge amount of processing to perform fast simulation. And of course, again, the designer have the full control of the design. So he is the one taking the decision, deciding which design solution generated by IDXplore is the best for his design in terms of performance, in terms of die, or whatever the key parameter which is important for each customer. And the last but not least, IDXplore being technology agnostic, this means that you can use this tool to any migration from one silicon technology to another silicon technology. And we support CMOS, we support BCD, we support FD-SOI, FinFET, gallium nitride, and silicon carbide. So very convenient when you are an IP provider and you need to move and build library for different technologies. We have also developed add-ons to our IDXplore, and here it's tools to perform fast corner analysis using what we call IDXplore PVT, and with the same principle for nominal exploration. IDXplore can perform very quickly the analysis of the design with the corner setup decided by the designer. And with the same principle of the nominal design, the designer will get all valid configuration of his design passing the PVT. And he will be able to select the best solution for him, for his design, which respect the specification of the design and also the specification of the corner analysis. Within IDXplore, we have also developed other features. So of course, PVT we just spoke about. We have also developed very interesting option, which is called cluster. And this simply enable to accelerate the simulation time by distributing the process over a computer farm. So here with this option, we just support the capability of when you have a computer farm in-house, you can parallelize and distribute your processing over this computer farm to, of course, accelerate complex simulation. And the last development is very interesting because IDXplore can perform very quickly the analysis of the design at SOC level. Means that you are here working you are working at a SOC level with multiple blocks. So you can explore simultaneously multiple analog blocks of a complex design and getting a lot of valid solution and being able to identify the interaction between the blocks and observe and analyze the SOC design with taking into account this interaction between blocks. So to summarize what IDXplore bring to the analog designer, I think probably the most important thing you have to understand is the capability of the tools to really drastically reduce the design time. And this is very important to increase the productivity of your design team, but also to help the designer across all his steps and having valid configuration, being able to select over different configuration the best solution for his design. Our tools is integrated in existing design framework, of course. So our target is not, of course, to impose, to change habits of the designer. So here, our idea is to keep the habit designers. And here, we are fully integrated, for example, in Cadence Virtuoso framework. And we are also supporting standard simulator on the market, so Cadence Spectre or Siemens Eldo simulator are also supported by IDXplore. So I explained before with the example from the customer, the use case from the customer. Our tool is perfect for transfer IP or IC to new technology and new foundries. So it's very fast and it's very easy to do the transfer. And as it is technology agnostic, it can address a lot of technologies. So it's perfect when you want to build an IP library and you want to make sure that all your IPs are available to any process. So of course, it is a clear marketing advantage for an IP provider to able to say to his customer, you have this IP available to any technology that you want to use. Important thing, and this is really part of our DNA and the DNA of the tools. Our tools is there to help the designer. It's not replacing the designer. So we give all the information for the designer to take the final decision. And this very important point is here we just help him by executing manual tasks, by automating some manual tasks, but in any case, at the end, the final decision is made by the designer. And all the tools is built and is done from the inputs of the designer. So the designer has the full control of the tool. And the last point, which is very interesting, because we have observed with our customers, thanks to the fact that our tools is very easy to use, it's also a fantastic tool to accelerate the learning curve of junior designer. So this is very interesting to see that some of our customers has used junior designer to make IP transfer, because of course, the initial design were done by an expert designer, but moving from one process to another process, as soon as you can reuse the initial design inputs, and you can use IDXplore, it makes the task of migration very easy, even for a junior designer. And also it helps the junior designer, thanks to all the data available generating by the tools, to analyze very quickly his design and understand the behavior of each parameter of his design. So it was my last slide. I thank you very much for your attention. I hope that you learn more about Intento Design and IDXplore. So I think now it's time to go to Q&A session. So please ask your question. I will try to answer. Thank you.